Now, of course, because of the symmetry or asymmetry between sine and cosine, we can do the same thing if we have the integral of sine to the mx cosine to the nx dx where m is odd. In that case, the substitution u equals cosine of x is going to help us solve this integral. Let's look at the integral of sine to the 5x times cosine to the 4x dx. Note that the power of cosine is even here, so the previous substitution, u equals sine x, will not work. If both powers were odd, then we would have options here. But as it stands, only the power of sine is odd, so we're going to make the substitution u equals cosine of x. So if we do that, then we must have a minus sine of x dx to be replaced by du. We can convert the even powers of sine to powers of cosine using sine squared of x equals 1 minus cosine squared of x. So let's see how this is going to work. We have u is cosine of x. The integral of sine to the 5x times cosine to the 4x dx is equal to the integral of sine to the 4x times cosine to the 4x times sine of x dx. That's splitting away that single power of sine to use for the du. And that's equal to the integral of sine squared of x squared times cosine to the 4 of x times sine of x dx. And now, replacing the sine squared by 1 minus cosine squared, we have the integral of 1 minus cosine squared of x squared times cosine to the 4x times sine of x dx. And now we're ready to make our substitution because everything in the integral has a cosine of x in it, or else it's going to be part of the du. Okay, so sine of x dx gets replaced by minus du because du is minus sine of x dx, and cosine of x gets replaced by u. So we end up with the integral of 1 minus u squared quantity squared times u to the 4 times minus du, which we can expand to minus the integral of 1 minus 2u squared plus u to the 4 times u to the 4, which is minus the integral of u to the 4 minus 2 times u to the 6 plus u to the 8. And we can integrate that using the power rule. It's minus u to the 5 over 5 minus 2 times u to the 7 over 7 plus u to the 9 over 9 plus c. And the last step is to replace the u by cosine of x, and we get our answer in terms, it's a linear sum of powers of cosine of x. Note that our substitution u equals cosine of x will work for odd powers of the sine function also. See, for example, the integral of sine cubed of x in the extra examples at the end of your notes. And this can also be solved by integration by parts, but if you can use a substitution, this is a much easier way of solving this integral.